I have always thanked my lucky stars for three things: for having been born in Brussels and not in any other city, for having studied mathematics rather than law, and for the fact that my professor was none other than Mr. Ketley.
Of the brief years he spent with his father, an expert in flower decoration, young Plateau retained only an awareness of the tenuous relationship existing between outward appearances and actual fact. The world around him was in turmoil. Empires were crumbling. In 1815, at the age of 14, he witnessed the Battle of Waterloo and painted this picture of the fighting. Politics left him unmoved. Ignoring the September Revolution, he spent his time analyzing the waters at Spa. By chance, he was born a Frenchman. Later, he became Dutch, but he was fated to be a Belgian and determined to be a scientist. The 19th century was the age of steam. The forces of nature were becoming the playthings of mankind. While simple folk marveled at the wonders of science, Plateau's questing mind sought to discover the causes of this perpetually shifting universe. His contemporaries were hardly conscious of the way in which science and industry were developing.
Most people are so accustomed to the phenomena around them that they do not try to understand what causes them. Usually their ideas on such matters are vague or entirely wrong, and very often they have no idea at all. They forget how closely physics are related to the everyday things of life. The only way to teach people physics is to reduce the whole science to a very few fundamental principles on which most of the rest is based.
Plateau's first research work was concerned with optics, a field that was still dominated by the theories of Descartes and Newton. Light reflection. Light refraction. Light dispersion. Based on Chevalier Darcy's experiments, Plateau's graduation thesis expounded the results of his research into the persistence of vision.
It takes quite a considerable time for an impression to register completely, and again for it to vanish completely. The total duration of an impression averages about 34/100ths of a second. It would seem that colors must be classified in the following order, beginning with the one which produces the most transient impression: red, yellow, and white.
Plateau was also one of the first promoters of photometry and colorimetry.
I have discovered that in most colors there is a shade coming somewhere between the darkest and the lightest tones which has the strongest effect of all the jumble of impressions received. I have designed an instrument which I call the anorthoscope that enables me to obtain the virtual picture produced by the movement of two curves. Sometimes I spend an entire day making all kinds of curves in the air.
To his contemporaries, Plateau's inventive genius smacked of witchcraft. He applied his discovery to the phenomenon of anamorphosis, a geometrical transformation that bends pictures erratically.
Any kind of figure, a man, a head, or a word, may be used as a fixed image. The instrument will then produce a distorted figure, which when made to turn at the same time as the predetermined mobile line, will give rise to a completely regular image. Here we have a new kind of anamorphosis. I found that if a wheel with perpendicular cogs is made to spin very fast, the image produced is one of absolutely motionless cogs.
Plateau was also a forerunner of stroboscopy.
So we reach the odd conclusion that the fast movement can be converted into a movement as slow as you like.
This is slow motion.
And the shape of a moving object can be detected by reducing it to apparent immobility.
This is the snapshot.
In Paris, I dined with Arago and spent an evening with Babinet. You can imagine how busy we kept the phenakisticope. The principle underlying this illusion is an extremely simple one. If for very brief moments, several objects of progressively different shapes or positions are placed before the eye in rapid succession, the consecutive impressions they make on the retina become linked together without blending into each other.
The phenakisticope is the first instrument to analyze and synthesize a moving picture.
I leave it to the imagination of people wanting to try out these experiments to make the best possible use of them.
Raynaud, Muybridge, Marais, Edison, and Lumière were the names of the imaginative people Plateau had in mind. The cinema was about to be born. With his friend Quetelet, the chief reformer of science in Belgium, Plateau spent many a night at the observatory in Brussels.
One summer's day in 1829, urged on by senseless curiosity, I stared fixedly at the blazing sun for 25 seconds in order to observe the subsequent effect on the retina. I experienced a very strong sensation of burning in my eyes and had to spend several days in a darkened room. Later on, I spread a black shawl on the floor, and in the middle, I placed a rectangular piece of cardboard divided into two equal squares, one red and the other green, colors which are complementary to each other. Standing with our backs to the windows, my family and I then fixed our eyes alternately on the black spots for a minute or so. Then, covering our eyes or looking at a light wall, we could see the two colored squares, but the colors had changed places.
Plateau was appointed Professor of Physics at Ghent University and continued his research into accidental colors. He was the first to associate them with the phenomena of persistence of vision.
We are as happy as can be, my wife and I, in our little house at number 18 Casino Square. In a fortnight, I hope to be able to announce the birth of a son and heir.
In 1840, a new field of research opened up before Plateau. It so happened that his laboratory assistant poured some oil into a flask containing a mixture of water and alcohol. Starting from this incident, Plateau set about reconstructing the experimental conditions of the phenomenon.
I have already worked out two methods whereby a liquid may be subjected to conditions such that it reacts as if it were weightless. The first is to introduce a quantity of oil into an alcoholic mixture, the density of which is identical to that of the oil. In this way, I eventually hope to obtain a Saturn effect, as well as other unexpected results. But it would be a great mistake if my experiments were to lead people to make deductions concerning astronomical phenomena. The attraction at work here is molecular attraction, and the forces which determine the shape of the oil proceed solely from an extremely thin superficial layer.
The existence of this force, superficial tension, was contested by many scientists at the time. But once again, the future was to prove that Plateau was right.
A second method makes it possible to produce balancing shapes in the air. When they float, soap bubbles are spherical, just like a submerged blob of oil. By means of an ordinary clay pipe, the bowl of which is first soaked in liquid glycerine, the bubble is blown up and deposited on a ring. Then you leave the room, closing the door very carefully indeed, and from time to time you observe the bubble through the keyhole.
By means of metal frameworks, Plateau demonstrated the existence of a vast number of balancing areas, and so confirmed the theoretical work being done by the surveyors of his period.
I should, however, emphasize one thing. I have been completely blind for many years now. Consequently, the spectator may be inclined to doubt the accuracy of my research. Let me reassure him on this point. Some of my experiments were carried out when I could still see perfectly. The others were performed in my presence, under my supervision, and every precaution I could devise was taken to prevent mistakes.
The English physicist, Faraday, who was for a long time one of Plateau's rivals, wrote about him in these words: "I have taken him, so to speak, for my guide, and I rejoice that the brilliance of his intellect sheds such glorious rays from the darkness in which his body is immersed."